Hello there. In this video we're going to do another special case of GA dealing with radicals and those square root graphs. So we'll try to graph this first. I kind of know where this one's going, so I made it really big. This one's the tricky one. So when you're trying to graph this, that square root sign, I know this is going to be a sideways parabola. It's just kind of a question of where it's positioned. So you can try inventing some points. Like if I plug in 0 there, I wind up getting 0 plus 1, so it's the square root of 1, which is 1. And then you have 1 minus 1, and that tells us that it's going to hit the point 0, 0. And then this may be a question of, okay, is it opening right or left? This one turns out, because the x is positive, it's going to open to the right. And you can say, well, how far back is it going to go? Oh, whoops. How far back is it going to go? Oh. And negative 1's the smallest that I can make the x value and still get an output. At negative 1, you got negative 1 plus 1, that's 0. Square root of 0 still works. Anything less than negative 1, negative 1.01, you're going to wind up with the square root of a negative. So at negative 1, you wind up with 0, and then you have 1 minus the square root of 0, which is 1. So there's that point. And this is actually telling us that the parabola, the sideways parabola, it's only half of 1, mind you. It's opening down. So there's our sideways parabola. And if you have questions about other points on there, say we put in the number like 3. 3 plus 1 is 4, square root of 4. That's so 1 minus the square root of 3 plus 1, then you got 1 minus the square root of 4. You're really doing 1 minus 2, so there's the point, like 3, negative 1. And it just keeps going down from there. But that's just an additional point on it. Let's do the other line. One is a y-intercept of 10, a slope of 1, so it's going to go through, or y-intercept of negative 10, so it's going to go through negative 10 and positive 10. Just keeps going like that. Okay, well, they intersect somewhere. I can kind of see it. I want to know where. I'm going to do the algebra. Okay, the square root sign really messes things up. I can't square this whole side right now. I'm just going to add more square root signs. It's going to be really, really gross. So I'm going to subtract the 1 first. And now what we're going to do is, now we can get rid of the square root sign because I have just a single big square root on this side, not 1 minus some square root thing. So we can square each entire side. And the nice thing about that is that that negative sign is going to disappear here when we square it. Negative times negative is positive. And on the other side, I can just do the trick because it's x minus 11, so double it, you get 22, and then the square of 11 is 121. Okay, well, now we can set it equal to 0. And we wind up with this lovely looking quadratic, and before we go running to the quadratic formula, this one actually turns out that you can factor it, right? Yeah, this one's factorable. As 8 plus 15 is 23, and 8 times 15, double 15 you get 30, double it again you get 60, double it again you get 120. So that works. And our solutions are at 8 and 15. And now we have an issue, because there's only one intersection, and the algebra is telling us there are 2. So we have to discount one of them. And you can kind of see from the graph here that it looks like it's the one that's less than 10, so it's really looking like it's the 8 there, not the 15. So I can cross that one out. That is a ghost solution, which is technically called an extraneous solution. So we don't have that one. If you want to know why we get that one, it's because in here when we squared things, we wound up creating a situation where there are 2 solutions. And if we go over to the graph and actually extend that line, or the parabola, kind of up so that it is a full parabola there, this would actually be that point there. Whoops, well, it's a little bit shifted, but that would be that point at 15. My scales are a bit off. This is the one that's at 8. So that's the one that I want. This one up here, that's the ghost solution. It doesn't really exist. and I just want the 8. Okay, I'll come back and talk about another way to get that one too. Now we're on the analyze part. Analyze, I want the square root 1, that curve, to be above the line. And that's true here. So in this whole region, it's producing values above the line. Before -1, there's nothing there. So we can't talk about that. This thing's not in existence. It can't be above the line if it's not in existence. Also, the line can't be above it if it's not in existence. So let's get our solution then. We know that this back here was at -1, greater than or equal to, and it can be at that value. So we got -1 up to 8, inclusive. -1 less than or equal to x, less than or equal to 8. And those are both of our solutions. I'm going to take a moment here to talk about another way to check which one is the ghost solution. The ghost solution, one that doesn't really exist. Okay. You can plug 8 and 15 into the equation. If I plug 8 in, I get 1 minus the square root of 8 plus 1. And that's 1 minus the square root of 9, which is 1 minus 3, which is -2. And on the other side, I had 8 minus 10. 8 minus 10, that's -2. Those are equal, they check out. If you do the other one, you get 1 minus the square root of 15 plus 1, which is 1 minus the square root of 16, which is 1 minus 4, which is -3. In the other side, you would get 15 minus 10, 15 minus 10, which is 5. And those are not equal to each other, so the 15's out. Now, if we had instead done this one as like a plus 4, you would have gotten 5. But square root sign, you only get the positive value, you're subtracting it here, that's why those are not equal to each other. That's the aberration up there. We want the one down there. Alright, that's a little bit long, and it sounds like it's news break time, so character and scholarship for life.